number 55. This is very similar to the worksheet that I passed out, the one titled Ball Just Clears Wall Problem. So here's the information we have. This ball is hit with an initial velocity that we don't know at an angle of 35 degrees above the horizontal. So what I did here is I broke that initial velocity that we don't know into x component, y component. Vy initial is sine 35 v initial. Vx is cosine 35 v initial. We know the acceleration x and y. There is no acceleration x, and acceleration in the y is down, negative 9.8. Now, the ball barely clears this wall. So what does it say here? The ball is hit. The ball just clears a wall. So you'll notice here they give you 21 meters. Notice in the diagram I put 20, because if you read the last sentence, this last sentence says, assume that the ball is hit at a height of 1 meter above the ground. Isn't that great? They put that in there at the end. How many kids, how many of you got stuck on that? So the very last sentence, so if the ball is hit from 1 meter above the ground and the wall is 21 meters high, what's going to be the vertical displacement that we care about? 20. So I did not incorporate the 1 meter above the ground into my diagram. I just made the wall 1 meter shorter. So we're going to say, for all practical purposes, the vertical displacement to clear the wall is 20 and not 21. Okay, so we're looking for the first thing, finding the initial speed of the ball. Finding this is the hard part of the problem. Would I put this on a multiple choice quiz? Way too time consuming. But this could be a free response question. It'd be a challenging free response. Hey man, look up here. This would be a challenging free response because of the algebra. So I'm going to erase the question. So we're solving for V initial first. Make sure this is saved. All right, so let's get rid of this. We have room to work. All right, so the key to the problem is you have to write an equation for the x direction and the y direction. So what could we say about the x direction? Well, there's only one equation for the x direction. X equals vxt, right? And then one thing to be aware of, the thing that connects the x direction and the y direction is time. Time in the x and time in the y is always the same. So rearrange this for t. You're going to get x over vx. But wait a minute, what's Vx? Vx is cosine 35 V initial. So T is x over cosine 35 V initial. So here's an equation for time. Yo.
Is x 130?
Yeah, x is 130. Is that right? Yeah. Oh, I thought you said I copied it wrong.
No.
You can substitute
Why don't you have one?
equation for x.
I wouldn't plug it in yet. Yeah, I mean you could go x like this and plug that in right there. We'll do that in a minute. Keep things in variables until you're ready to plug numbers in. Okay? Okay, so now what we do is we go to the y direction and let's write an equation for what's going on in the y. So y, hey, the most commonly used kinematic is the first one. I don't know if you've noticed that. The first one on the list of kinematics is the most commonly used. Y equals 1/2 gt squared plus vy initial t. So I wrote that kinematic specifically for the y direction, and now let's plug into it. So let's take our equation for time, plug that there, and plug it there. And then also Vy initial. Vy initial is sine 35 V naught. So plugging in, we're going to get y equals 1/2 g. Now here's why I would not put this on a multiple choice. X over cosine 35 V initial squared plus sine 35 V naught, so that's Vy initial right there, times x over cosine 35 V naught. Okay, now this cleans up quite a bit. It cleans up. So for example, see the V initials here? Those V initials cancel. Anybody know what sine over cosine simplifies to? Tangent. So I'm going to rewrite this again. So y, so cleaning this up, we're going to get y equals g x squared over 2 cosine 35 squared V initial squared plus tangent 35 x. All right, now looking at this equation right here. Looking at this equation, the only thing that we don't have is V initial. So now it becomes algebra. But I want to make you aware, look, you have to plug gravity in as negative 9.8, right? And then what's this y going to be? 20. And then what else? X is what? 130. And then x is 130. So you know what? I'm going to let you guys do the algebra. You can do this. It's like solving for x. The only thing missing in here is V initial. So you solve for V initial from that equation, and you get 41.6. So that is this velocity. That's the velocity that's at a 35-degree angle. This would be too much for the multiple choice. V initial comes out as 41.6 when you solve the algebra. So the key to the problem, guys, the key to the problem here is write an equation for the x, which isn't too bad because there's only one equation for the x direction. Solve it for time, and then plug it into a y equation. The thing that connects the x and the y is time. Okay? Okay, so having done that, can I erase this? Okay, so now that we know this V initial is 41.6, so solve for Vy initial, solve for what it is, and then Vx initial. The rest of the problem could be on the quiz for sure. The rest of the problem, like if I gave you that initial velocity, I could ask you, what's part B? The time it takes to reach the wall. That's definite quiz question. So solving this for Vx, we get 34.14. 34.14. Vy initial is 23.86. Okay, so how do we go about doing part B? The time it takes to reach the wall. Are we going to use the x direction or the y direction? You could really use both here. You could figure out time with the x or the y. There's enough info. The x is definitely going to be easier. So using the x direction, x equals vx times t. So time is going to be equal to x over vx. So how far does the ball go in the x direction? 130 meters. The x velocity is 34.14. So this gives 3.8 seconds to reach the wall. And then you could also do it with the y direction. Solve it. You could try solving it with the y direction as well. There is enough info. Okay, last question. Find the velocity components and the speed of the ball when it reaches the wall. So we now have time to the wall. Let's just write that down. We now know the time to the wall is 3.8 seconds. So this final question, when the ball passes the wall, you know, it's traveling like that, right? The velocity's at an angle, so it has x component and y component. In fact, let me make this nicer. Let's redraw this. So as the ball, here's the ball passing the wall, right? It's going like this. It has x velocity and it has y velocity. So it's asking for the components. The velocity components. Well, we already know this component. What's the x component? Yeah, 34.14. That never changes. And you have to solve for the y component. You got to solve for the y component using a kinematic. So you go Vy final equals Vy initial plus GT. So Vy final. So Vy initial was 23.86 plus negative 9.8 times 3.8 seconds. I left the units off because I'm out of room. So Vy final comes out as negative 13.38 meter per second. And then to find the total speed, right here it says the speed of the ball, that's this right here. So how do you do that? Pythagorean theorem. Pythagorean theorem, it comes out as 36.7 meter per second. So the answer to part C, here's what they're looking for. X component, 34.14. Y component is negative 13.38 meter per second. And then the total velocity is 36.7. Pythagorean theorem. To get this, you do Pythagorean theorem. Yo.
And so the x doesn't change because there's no acceleration, right?
The x velocity is constant.
Okay.
Yep.